We spent some time in class trying to recognize these different functional groups that you see on the slide. We are going to, in these videos, and I'm going to have a series of them, we're going to look at properties and details about these. This class is chemistry in your, basically your everyday world, molecular science for citizens. I want you to see where you would see these chemicals. I want you to understand the properties that they would have based upon these functional groups. Okay, so let's start with, we're not going to spend time with ethers. We're going to start with alcohols. So we know that this is the functional group of an alcohol. It has an OH group attached to a carbon somewhere within that molecule. What we want to know is what kind of properties does that give it, and where are we going to see that commonly? The first alcohol, the simplest alcohol, is methanol. And methanol is not for drinking, okay? There's an alcohol out there that we can drink, but we would not want to drink this one. If you were to just consume small amounts of methanol, what would happen is it could cause small amounts is going to actually happen naturally, okay? Some things are going to have little bits, and your body can do the small amounts. What happens if you're getting large amounts? If you're going to have blindness first, typically, and then it can cause death even. Now, there are some people out there that are not susceptible to methanol as an issue. They can take care of it, but it is a very rare thing. Most people are going to become blind from it. People who have really poor sources of an alcohol they're trying to make their own might end up producing methanol in the process, and if so, they could be causing blindness or death from consumption of it. Okay, so here it says a little as 1 ounce could lead to blindness. That's not very much, okay? And a cup is to 8 ounces, right? So just a little bit there could lead to blindness if you consumed it rapidly. All right, so now some alcohols are toxic, some alcohols are not toxic, and there's tables that tell you about the toxicity of this. Okay, and so we call this a lethal dose. That's a good name of it. And this way of defining toxicity is what we call an LD50. Okay, lethal dose for half the people. Okay, how much would you have to take in order for half the people who consume that much to die? That's what an LD50 is. For many people, a lethal dose of ethanol is about 10 grams per kilogram of body weight. Now, I weigh somewhere in the range of 50 to 60 kilograms, depending on where I am in my life of weight loss, okay? So there is a typical range for me. So 10 grams per kilogram, if I have 50 to 60 kilograms, all right, that's going to be 50 or 60 kilograms times the 10 grams that I could consume before I would have any issues. Okay, so here we see the description that I was talking about in that language. LD50 is what you could consume where only half the people would die, half the people would survive. Now, we don't do LD100 because you don't want to know what's going to kill everybody. What you want to know is, okay, I don't want you to die. Don't go to this amount, or half of you will. Okay, it is kind of a rough scale because different people can tolerate chemicals differently than other people. We have different enzymes and different ways of dealing with chemicals within our body. That is a genetic disposition for you. So here are various alcohols, and what I want you to kind of get from this is how this LD50 scale works. I don't want you to memorize these numbers, okay? So ethanol is the one that is drinking alcohol, and this is 7 to 10, and this is in grams per kilogram of body weight. So if you took this and multiplied by your body weight, if you knew it in kilograms, let's say I was 50 kilograms, okay, so on the big scale, on the big end, I could have 500 grams of ethanol without, well, if I got up to 500 grams of ethanol, half of the people with that much who weighed my amount would die. Now look at this one, propanol. Propanol's LD50 is smaller. Now, a lot of people would say smaller, oh, that means it's better. No, that's not what that means. If this number is smaller, then you're going to get to it quicker. So for me, let's round that up to 2, so it's an easy number. Let's say it's 2. If I were 50 kilograms, you could only consume 100 grams, and then very conceivably, half the people who consume that much would pass away. So we've got low numbers on the LD50 scale are more poisonous than high numbers. Does that make sense? The smaller numbers means you consume a smaller amount, half the people are going to pass away. All right, let's talk specifically about alcohol, because alcohol would be the one that most people would be familiar with, be exposed to, and so we're going to kind of talk about how our body processes this. So this is a history of a can of beer in the body. So beer is a 12-ounce can typically, okay? It is only going to contain 14 grams of alcohol, and this would be about the same for a glass of wine, okay, or a shot of whiskey. 14 grams of alcohol. So they define a dose. That's not the right word, but they define it based upon having 14 grams. So the first thing that's going to happen when you drink the alcohol, so number 1, when it hits the stomach, which is right here at number 1, it starts absorbing that alcohol into your bloodstream. So it does not have to go into the digestive tract in order to feel it. As soon as it hits the stomach, it is going to start getting absorbed into the bloodstream, and you can start feeling that effect. All right? Once it hits the small intestine, so that's the next place it goes, it's going down into the small intestine, you're going to absorb it also into the bloodstream. And it's going to absorb more quickly than any food would. So if you're drinking alcohol and eating, you can feel the effects of that alcohol quicker than you're going to feel the effects of the food in your body. All right, the third thing, this is the liver, okay? So we have the liver here. The liver's job is to break down things in our body, and it is going to break down this alcohol. It will ultimately break it down into oxygen and carbon dioxide. That's what the enzymes in that liver do. Now, if it doesn't break it down, okay, if you have some that didn't get broke down and it's working its way through, it can be absorbed, and then it can be absorbed by the kidney, and it can go out into the bladder, or it can be released as sweat. It's very similar in some ways to water with that OH group on there, and water, of course, is HOH. So it can come out as sweat as well. It can also, if it's metabolized, okay, if it doesn't break down, as it's working its way through the bloodstream, it's going to enter the lungs, and you can exhale some of it. And that is what they're going to pick up on when you do a breathalyzer test. The more that's unmetabolized and is running through your blood, the more you're going to exhale when you are, breathing. Okay, and number 6, it can make its way eventually, of course, to the brain. It can actually affect the brain. Now, not everything you take can get into the brain. There's a pretty good barrier, blood-brain barrier, so a lot of things cannot get into the brain that you can consume, but this is one that can. So then this actually can affect your brain and your nervous system. And if you've ever consumed alcohol, you would know that feeling, and it can be to greater and greater extents depending upon how much alcohol you consume. Okay? So about 90% of the alcohol is consumed is actually broke down, and that's usually the job of the liver. A little bit of it is going to be excreted, so about 90% of it's going to actually get broken down. Some of it is not going to, and it's going to go into the urine, and a little bit is going to be exhaled by the lungs. So those are the ways typically once you consume alcohol, as a summary of what's going to happen as it goes out. It's either going to get broken down, it turns into carbon dioxide and water. That's exhaled just like anything else when you exhale, carbon dioxide and moisture. Some of it is going to go pass through the kidneys on your body that way, so you can do a test with urine to see how much alcohol you have, and some of it's going to be exhaled because it didn't break down as you exhale. So that's what the breathalyzer works on. You breathe into a tube, okay, and that chemical is going to get absorbed into some of that alcohol, the CH3, CH2OH. Some of it's going to get absorbed into a chemical. Now this is a very simplistic model, but a light is going to pass through that, and they're going to see how much of that light gets absorbed by the the ethanol. That's going to be read on a gauge, and they're going to be able to say, all right, this is going to be the blood alcohol content in your body based upon how much was in your breath. All right, let's look at some other alcohols. Let's look at ethylene glycol. This is an important one for us. This is in antifreeze, okay? So in your car, they put ethylene glycol. What do we got? That ethylene language. We see the ethyl, we see the E-N-E. That's the old-fashioned way of saying ethene. This is the common name of ethylene, of this compound. This is not the name that you would have learned when we learned our naming system, and we'll talk about this. But it is poisonous. Okay, it will kill you, and they've got cases where maybe animals have gotten into the antifreeze and have died from this poison. The other one seems like it's awfully similar, and this is called glycerol, and glycerol is 3 carbons instead of 2, with an OH group on each of them. So up here on the ethylene glycol, it's 2 OHs and 2 carbons. Here it's 3 OHs and 3 carbons. So it seems like it is so close that it ought to be awful, but it's not. It's fine. It's seen in a lot of things that we consume, that we put on our skin, and it actually has a bit of a sweet taste to it. If you look at soaps, okay, soaps are going to have in there glycerol because soaps are made out of fats. And we're going to see when we get into our biochemistry unit where that glycerol comes from when you're dealing with fats. Nitroglycerin you may have heard of in terms of people who've got heart conditions need nitroglycerin for that. And so we have nitrogen oxygen groups attached to where the OH groups are, and that's a nitroglycerin. So what would we have called this when we learned how to name this? Well, the 2-carbon chain, what is that? A 2-carbon chain is ethene, so we have our ethane. So we have that as its root name, and then we have 2 OH groups. So instead of ethane, it would be ethanol, okay? But now there's 2 of them, so it's that should be an A, ethane, and we didn't do this, diol. Okay, we have 2 alcohol groups, and then you locate them. It's on the 1st carbon and the 2nd carbon. So more neatly up here, 1, 2, okay, and then ethane diol would be the name of that molecule by our naming system. But nobody calls it that. Everybody calls it ethylene glycol. Okay, that common name has stuck so much more than the IUPAC system that we learned. So what would this one down here be? Well, it's got 3 carbons, so we know it's propane. And there are 3 OH groups, so it would be tri, TRI, OL for 3 alcohols. And where are they located? 1, 2, 3. So that would be how we would use it for the system that we learned, but nobody calls it that. Glycerol, or sometimes glycerin, that's another way to say it, is this 3 carbon with 3 OH groups. PVA is polyvinyl alcohol. And PVA, here the monomer would be a double bond here, okay? But we break the double bond and link these together. So this is, this guy would be called vinyl alcohol, okay? It's the double bond, that's the vinyl part. It's got an OH group, that's the alcohol part. And then once you link it together over and over again with these units over and over again, it becomes polyvinyl alcohol. Polyvinyl alcohol is a polymer that has a unique property of being soluble in water. So it is water soluble. It is actually used like an Elmer's glue. It's a thickening agent and causes it to thicken up. and that is polyvinyl alcohol. So let us stop there with our alcohol discussion. We have worked through the various alcohols. We know that most of them are poisonous, and even the drinking alcohol is poisonous to a certain level. And then we've looked at two common ones, the antifreeze one and the one that is actually in cooking and foods and on makeups that we take in. Those are ones that you're going to see when you're doing your not your hands-on project, your real-life activity that you're going to be doing at the end of this unit. So those are the alcohols. We'll move on to the next one with our next video.